In this one, we want to match the different pictures to the appropriate coefficient of determination. We have values of r squared as high as 0.98 and as low as 0.0016. So what the coefficient of determination measures is how well any sort of curve that you fit, whether it be a line or an actual curve, fits to your data. It does not just measure a linear fit like the correlation does. So we want to look here at the fitted lines or curves as represented by the dashed lines and see which ones do a good job of modeling the data and which ones do a poor job. Good job is going to be r squared closer to 1, poor job closer to 0. So if we wanted to look for the 0.98 r squared, we're going to look for which points are closest to the fitted line, and that's going to be this one right here. This is the one where we see the strongest relationship between the points and what was fitted. Next, we want to look for r squared of 0.79. We have in the first plot a linear relationship. We do have quite a bit of scatter of the points around the line. We also have this curve over in the last one, on plot 4, where the points seem to be a little bit closer to the line than they did for that linear fit. So r squared of 0.79 is going to correspond to this one. So it can be close to 1 when you have a fit that's nonlinear, as long as that fit is a good fit. And that curve there is a good fit to that data. Then what we're left with is 0.32 and a 0.0016. Let's talk about this plot here for a second, plot 3. We see a fairly strong curvature to those points, but the curve was not fit there. What we fit to the points was this line, which ends up being almost a horizontal line because of the fact that the shape isn't really linear, and we're fitting a linear to something that's nonlinear. So this is the one where the line that we fit does a very poor job of modeling the data, and that's going to give us that really low r squared. Then what we're left with is the r squared equal 0.32. So we can see here that we have a linear relationship, but it's not very strong, so we have a 0.32, a low r squared for that one.